Once you have designed and laid out duct systems, you can analyze those systems in several ways. Let's take a look at a few methods. In this project, there are 3 duct systems in the south portion of the building. I'll zoom into this area. When you select a duct in a duct system, there is an analysis panel that appears on the Modify Ducts contextual ribbon. One of the tools available is the System Inspector. I'll click System Inspector to activate the tool. When I do, a System Inspector panel appears in the drawing area. You can move this panel as needed. To begin inspecting the system, click Inspect. Once I do, arrows appear in the system indicating the direction of the flow. Also, an icon appears next to my cursor indicating Revit is in inspecting mode. Now when I move my cursor over any of the elements in the system, a tag appears showing the flow, static pressure, and pressure loss information at that point. When you move over an air terminal, you can also see the total pressure and excess pressure. Also, be aware that Revit does not just calculate one value for each duct segment. For example, each of the horizontal ducts has 2 taps near the right end. When you move your cursor over the duct to the left of the taps, you can see the flow before the taps. Then, when you move your cursor over the same duct to the right of the taps, you can see the decrease in airflow. Revit is smart enough to realize that there is a tap and the airflow after the tap decreases. Also, if you click on any element when the tag appears, the tag will temporarily be placed in that location. You can continue to move your cursor over other elements and another tag will appear. But when you click to place the tag in a new location, the previous one disappears. Only one tag can be placed at once. Once you are finished inspecting the system, you can click Finish in the System Inspector panel. When you do, the flow arrows no longer appear and any tag that was placed is removed. Another way to analyze a system is to create a duct legend. To create a duct legend, on the Analyze ribbon in the Color Fill panel, click Duct Legend. Note that the Color Fill panel also appears on the Annotate ribbon. Once you activate the tool, a legend appears on the end of your cursor, and you can simply click to place the legend. Next, select the legend that you just placed in the drawing area. In the contextual ribbon, select Edit Scheme. Revit displays the Edit Color Scheme dialog. There are 3 areas in this dialog: Schemes, Scheme Definition, and Options. Include Elements from Linked Files is the only option under Options. In the Schemes area, Ducts is the only category available in the category drop-down. There are also 2 schemes already created. When you select a scheme in the list, you can then see the scheme definition. Let's take a look at the flow scheme. As you can see, there are several flow values in the value column. Each one of these is marked as visible and has a specific color and fill pattern assigned. If you use this scheme, you can quickly see where there is not much airflow versus where there is plenty of airflow simply by looking at the colors of the duct. I'll switch to the velocity scheme. As you can see, this scheme is a bit different. Besides using a value, this scheme uses a range. This is controlled by the radio buttons above the table. Also, in the color drop-down, you can see that it is set to velocity. When you expand the drop-down, you can see that there are several options to use when creating a color scheme, such as friction, pressure drop, velocity pressure, and so on. I'll modify this velocity color scheme because I want to check the velocity in this ductwork. I really don't need the last 2 rows because I shouldn't have anything that high in this low velocity system. So I will click in the last row and then select Remove Value. Revit displays a warning asking if I want to remove the entry. I'll click Yes. I'll also remove the next to last entry. Now I can use these values. I really do not need any of the ductwork to have a velocity greater than 1,200 feet per minute, or 6 meters per second in the metric file. So I'll click the button in the color field for the last row to open the color dialog. Then I'll change the color to red and click OK. At this point, this color scheme can be very useful. All the main ductwork should be green and the branch ductwork should be blue, if designed properly. If anything is red, I will need to take another look at the duct size and the airflow in the air terminals. I'll click OK to apply the color scheme and close the dialog. Back in the drawing area, everything looks good and it appears the system was designed properly. Remember that you can use several parameters to analyze a design by applying a duct color scheme. Just to see if a duct would indeed turn red if the velocity was too high, I'll select a diffuser and change the flow to 1000 CFM or 470 liters per second in the metric file. Once I do, you can see that some of the ducts upstream turn red. Using duct color schemes is a great way to analyze duct systems.